The secondary flight controls add lift or drag and help in flight path adjustment. The spoiler's speed brakes help roll the airplane, add drag to slow the airplane, or increase the rate of descent. The leading edge devices add lift for slower approach and landing speeds. The trailing edge flaps also add lift and drag for slower approach and landing speeds. Each wing has 4 flight spoilers and 2 ground spoilers. The flight spoilers are operated manually in flight to slow the airplane or increase the rate of descent, or automatically to help the ailerons in roll control. You must be careful when you operate the flight spoilers manually and the airplane is turned. The airplane roll rate can quickly increase. The ground spoilers operate with the flight spoilers on the ground. The flight spoilers use hydraulic systems A and B. The ground spoilers use hydraulic system A. The controls and indicators for the spoiler speed brakes are found here. The speed brake lever is on the captain's side of the control stand. In the down detent position, all flight and ground spoiler panels are down. The armed position is for automatic operation. In the flight detent position, all flight spoilers extend to the maximum position. In the up position, all flight and ground spoilers extend to their maximum position. The up position is used only on the ground. The speed brake armed light is on the captain's instrument panel and shows that the speed brake system is armed for automatic inputs. The speed brake's extended light on the first officer's instrument panel illuminates in flight when the speed brake lever is out of the armed position and the trailing edge flaps are extended to more than flaps 10, or radio altitude is less than 800 feet. The speed brake's extended light illuminates on the ground when the speed brake lever is in the down detent position and the ground spoilers are not stowed. The spoilers are set to operate automatically on landing or during a rejected takeoff. To operate automatically on landing, you must have the speed brake lever in the armed position and the speed brake armed light illuminated. The thrust levers in the idle position, a main landing gear wheel speed of more than 60 knots, and a landing gear strut compression. When the left main, right main, or nose gear strut compresses, the flight spoilers move up. When the right main gear strut compresses, the ground spoilers move up. During a rejected takeoff, all spoilers operate if the auto brake select switch is in the RTO position. Main landing gear wheel speed is more than 60 knots. The thrust levers are in idle. And the reverse thrust levers are moved to reverse thrust. The spoiler switches on the flight control panel are for maintenance use only. The leading edge devices and trailing edge flaps are high lift devices that increase wing lift and decrease stall speed during takeoff, low speed flight, and landing. The leading edge devices are the leading edge flaps, which have two positions, up and full extended. And the leading edge slats, which have three positions, up, extended, and full extended. The trailing edge flaps are double slotted. Extension of the leading edge devices occurs in sequence with the movement of the trailing edge flaps. The leading edge devices and trailing edge flaps use hydraulic system B. The standby hydraulic system is the alternate source for extension of the leading edge devices. An electrical motor is the alternate system for extension and retraction of the trailing edge flaps. Alternate flap and slat operation is discussed in a different lesson. The flap lever is on the first officer's side of the control stand. When the flap lever moves, the trailing edge flap control and leading edge control operate, and hydraulic pressure goes to the trailing edge drive unit and the leading edge slats. The flap position indicator shows the trailing edge flap positions. Flap gates prevent accidental movement through position 1 during a single engine go-around and position 15 during a normal go-around. The flaps limit placard shows the maximum speed for each flap position. The Flap Slat Electronics Unit, or FSEU, supplies trailing edge flap load relief from higher than normal airspeed for flaps 40 and 30. The FSEU tells the flaps to retract from 40 to 30 if the airspeed is more than 163 knots. When the flap lever is set to 30, the flaps retract to 25 if the airspeed is more than 176 knots. The flap lever does not move, but the flap position indicator shows the retracted position. The flaps extend to the set position when the airspeed decreases below 158 knots for flaps 40 or below 171 knots for flaps 30. Indications for the leading edge devices are on the center instrument panel and the aft overhead panel. The leading edge devices annunciator panel shows the position of each leading edge flap and slat. The leading edge flap transit and extended lights show the condition of the leading edge devices. When all the lights extinguish, the devices are retracted. The amber leading edge device's transit lights and leading edge flaps transit light illuminate when the leading edge devices are in transit or not in the correct position. The green leading edge device's extended or full extended lights illuminate when the leading edge devices are in the correct position. The leading edge flaps extended light illuminates when the leading edge flaps are in the full extended position and the slats are in the extended position. Or the leading edge flaps and slats are in the full extended position. Push and hold the test switch. The test switch illuminates all annunciator panel lights. The auto-slat system increases wing lift if the airplane approaches a stall during takeoff or approach to landing. With the trailing edge flaps set at 1, 2, or 5, the auto-slat system moves the leading edge slats from extended to the full extended position before stick shaker. The slats move back to the extended position when the pitch angle is below the stall attitude. The auto-slat system uses hydraulic system B. If pressure from the hydraulic system B engine-driven pump is not sufficient, the power transfer unit, or PTU, uses hydraulic system A to pressurize system B for auto-slat operation. Let's look at a flap extension sequence. Set flaps 5. When the flap lever is set at 5, the trailing edge flaps move from the up position and the leading edge devices start to extend. The leading edge flaps transit light and leading edge devices transit lights illuminate. When the trailing edge flaps near the 1 position, the leading edge flaps are at full extended. The slats are at extended, and the leading edge flaps extended light illuminates. Set flaps 40. When the trailing edge flaps move from flaps 5 to flaps 10, the slats move to full extended. The lights again show in transit and then full extended. Only the trailing edge flaps continue to extend from flaps 10 to flaps 40. Let's look at the non-normal conditions related to secondary flight controls. The speed brake do not arm light is on the captain's instrument panel and shows the automatic speed brake system is inoperative. During the landing roll, you must manually move the speed brake lever to up. The auto-slat fail light illuminates when the auto-slat system is not available. The flight controls system annunciator and master caution lights illuminate. A failure of a single SMYD channel illuminates the auto-slat fail light, flight control's system annunciator, and master caution lights when the master caution system recall is activated. No crew action is required for an auto-slat system failure. If hydraulic system B does not operate, the standby hydraulic system is the alternate source for extension of the leading edge devices, while an electrical motor is the alternate system for extension and retraction of the trailing edge flaps. The alternate flaps master switch and position switch control the alternate flap system. Open the guard and move the master switch to arm. When the alternate flap master switch is in the arm position, the alternate flaps position switch is armed. The standby hydraulic pump turns on, and the trailing edge flap bypass valve closes. Next, move the alternate flaps position switch to down. In the down position, the standby hydraulic system moves the leading edge flaps and slats directly to the full extended position, while an electric motor extends the trailing edge flaps. The down position is spring-loaded and must be held until the flaps reach the correct position. Trailing edge flap extension is slow and can be as long as 2 minutes for the flaps to move from up to flaps 15. To retract the trailing edge flaps, move the alternate flaps position switch to up. The up position is magnetically held. Leading edge flaps and slats stay fully extended and cannot be retracted by the standby hydraulic system. The additional drag can cause your reserve fuel to not be sufficient to fly to an alternate airport. The FSEU monitors the trailing edge flaps for asymmetry and skew conditions, the leading edge devices for an incorrect position, and the leading edge slats 2 through 7 for a skew condition. A flap asymmetry occurs when a flap on one wing is not aligned with the same flap on the other wing. A skew condition occurs when the two drives for a flap or slat panel do not operate at the same rate and cause the panel to twist during extension or retraction. When the FSEU senses a trailing edge asymmetry or skew condition, the FSEU closes the trailing edge bypass valve and you see a needle split on the flap position indicator. If an asymmetrical trailing edge flaps condition exists, do not attempt to move the trailing edge flaps with the alternate flaps position switch. There is no asymmetry or skew protection when the alternate flap extension system is used. When the FSEU senses a leading edge flap or slat not in the correct position, or a leading edge slat skew condition, the leading edge flap's transit light stays illuminated. And one of these indications is shown on the leading edge device's annunciator panel. An amber transit light illuminates, an incorrect green extended or full extended light illuminates, or no lights illuminate. There is no skew detection for the leading edge flaps or slats 1 and 8, and a slat skew is not monitored during autoslat operation. The FSEU also monitors uncommanded motion of the leading edge devices or trailing edge flaps. Uncommanded motion for a leading edge device occurs when the trailing edge flaps or autoslats are not commanded, and two leading edge flaps move on one wing, or two or more slats move on one wing. In this example, the flaps are up and two slats moved. The amber leading edge flap's transit light illuminates, the FSEU stops the operation of the leading edge control, and the leading edge device is held where it is. The FSEU monitors the trailing edge flap position and compares it to the commanded flap position. If the flaps move when there is no flap lever command or flap load relief command, or they move in the opposite direction of the flap lever, the FSEU closes the flap bypass valve and the flap movement stops. The only indication is the flap indicator and the flap lever position do not agree. In this example, the flap lever position is at 5 and the indicator shows between 1 and 2. Alternate flaps is used to control the trailing edge flaps because the flap bypass valve cannot be reset by the flight crew. Remember, there is no asymmetry or skew protection when the alternate flap extension system is used.